Water, like any substance, is made up of molecules. The mobility of these molecules is determined by temperature. When heat is added to water, the vibration of its molecules increases, causing the water to expand. As the water molecules vibrate faster, they bounce around, pushing each other away, causing the space between them to increase. This graph shows how the volume of water expands as its temperature increases from 4 degrees Celsius to 18 degrees Celsius. Here is a graph showing the increase of water volume over a larger range of temperatures. However, there is an important anomaly that should be noted. When you zoom in on the graph between 0 and 4 degrees Celsius, you'll notice that there is no expansion in this range. In fact, there's a slight decrease in volume. This is due to water's unique property of having less density as a solid than as a liquid. This can be explained by the crystalline structure of ice. When water molecules cool down, they vibrate less. As the temperature reaches freezing, these slow-moving molecules latch onto each other at specific points, creating rigid ice crystals with a distinctive lattice shape. The relatively large space between frozen water molecules is the reason that ice is more voluminous than water and likewise less dense. As ice is heated from 0 to 4 degrees Celsius, it begins to thaw. However, because melting is not an instantaneous process, the water molecules transforming from the crystalline state to a liquid are decreasing in overall volume, while the water molecules absorbing heat in the liquid form are increasingly more active, which increases volume. However, because the collapse of ice crystals dominates these two opposing processes, the net effect is a decrease in the overall volume. Once the water reaches 4 degrees Celsius, however, expansion takes over as most of the ice crystals have melted and the freely vibrating water molecules can move about with increasing mobility.